If you want to know what we do in a nutshell, in a sentence, it's creating clarity from chaos. That's what it's all about.
That's really good. That's really good.
I'll leave you with that.
Good morning, good afternoon, good evening, wherever you are in the world, and welcome back to the MineWarp podcast. This is, of course, the podcast where we talk about everything new and exciting coming to us in the world of mining and natural resources, and all of the technology, specifically focusing on digitization, automation, electrification, and related innovation. And we are speaking with innovators and igniters that take innovation to the market, and investors and implementers at mines, and all kinds of people who are role players or stakeholders in this industry. This morning we have another interesting guest for you, and his name is Ahmed Kader. He is Operations Director at CrystalForge Technologies. Welcome to the podcast, Ahmed.
Thanks, MP. How's it?
Yeah, good to have you here. And now, as usual, we're going to start a little bit with your personal journey. You are a chemical engineer of background, if I'm not mistaken, at my alma mater at University of Pretoria. I also saw you've got a master's where you combined your research, in energy and quantum field technology with your chemical engineering. And I thought to myself, my goodness, that's not the most obvious path into mining technology that I've seen before. Though I guess quantum field technology does deal with complexity and unseen interactions, which is in some ways somewhat similar to mining.
Yeah, so that was quite an interesting sort of story, because we were looking at the energetics of quantum field theory-based systems to figure out if we could use that to predict the performance of battery technologies and what sort of elements you should use to produce a battery of a particular energy density and a particular quality. It's still the case at the moment that most of the battery research, or a lot of the battery research, depends heavily on experiments. Which, the idea behind using quantum field theory is that you can get an accurate picture of the underlying energetics, and then you could, hypothetically at least, predict what elements in what sort of ratios to use to produce a battery of a different kind, or a superior quality, or a superior energy density or size, or whatever factor you cared about. So yeah, that was the basis of that. And we were trying to, a lot of what I've done is say, okay, we've got chemical engineering as the base sort of skill set that you've been equipped with. But, chemical engineering is a very broad field. And there are a lot of intersections with other fields and other interesting theories and practices. And my habit has always been to try and integrate those into the core skill set and figure out where does the opportunity lie for us to use the intersection of those different concepts to drive performance, to produce better technical results, or whatever the case might be at the time. So yeah.
That's an interesting background. I had to chuckle internally when you talked about predicting stuff using quantum theory, which is, I guess, ontologically uncertain. But anyways, let's not go down that rabbit hole. I wanted to ask you, so how did you end up in mining?
Okay, so the key was that I had a bursary from a mining company.
Okay, that helps.
Yeah, that always helps. And a lot of my family were in mining. So I've got an uncle who's still an instrument specialist. Got another one who's a millwright out in Saudi. Another one is a chemical engineer. Another one is a mechanical guy working in equipment, in mining equipment. So there was a lot of that going on. But at the same time, it was something where I felt that, being so far up the value chain, you're close to the source, in terms of the resource and that sort of thing.
Yeah.
And I always felt like efficiency there makes an impact all the way down that value chain, right through to consumer goods, right through to whatever the final use case of that material is. You're impacting the bottom line of that entire value chain.
Downstream kind of
process.
Yeah.
I mean, think about, like, if we make copper slightly more efficiently, every single copper wire is cheaper. You know what I'm saying? If we drive the cost curve for copper down by 10%, that's insane value globally. And you can't really calculate it and you can't really count it. But I felt like if you are going to contribute, it's probably a good place to do it.
Yeah. Plus, it's pretty hard to avoid mining if you're a South African.
Oh, yeah, sure.
So shout out to all the uncles out there, and welcome to mining, I guess. So very quickly, CrystalForge Technologies. If you were to explain to those listeners who don't know yet, what exactly does CrystalForge do, and how would you describe the core offering to someone who's maybe not that deeply technical?
So in a very, I'm going to try and keep it concise just in the interest of time, but in a nutshell, it's, think about running your laptop, right? It's a pretty complicated piece of hardware. There's a GPU, there's a CPU, there's some RAM, all sorts of other bits and bobs. And all of us use some sort of operating system to run this complicated piece of hardware that we own.
Right.
And whether it be Windows or Apple or some other operating system, Android in the case of your phone, which is also basically just a computer. But then on a plant, which is infinitely more complex and a lot bigger piece of hardware run by a lot more people, we don't really have the concept of operating systems for an industrial operation. And that was one of the things that in industry, while I was working and with my colleagues, we were trying to get to a point where we have an integrated operating system for a plant that allows it to perform optimally under any set of conditions or almost any set of conditions, while also simplifying the process of interacting with the plant for the human teams that are trying to do this, and integrating the technology, empowering ourselves. And this whole cacophony of ideas stems from the foundational principle that you can produce customized software for anything if you really know what you're doing. And so CrystalForge Technologies produces bespoke, tailor-made solutions to produce a business operating system, an industrial operating system for the plant that integrates AI, that integrates machine learning, basic software engineering, and also all your cloud native paradigms and the technical know-how behind how do you actually run an industrial operation. One of the key things that's been missing, in my opinion, from software and mining for a long time has been mining professionals. So industrial professionals that have actually run a plant, that have actually been to a mine, that have actually done the hard yards of working on a shift. And those guys or those people being involved in the generation of the software for the industry makes a world of a difference. And that's what we do.
I had a colleague who used to say that engineers create or solve mining problems by creating software problems, So, and I say that kind of tongue in cheek, but this customization game that you're talking about is not that easy. And if you're not careful, you can very, very quickly create a bowl of spaghetti that is only accessible and understandable to the engineer that created it.
Yes.
So what do you do to, well, you say you create this operating system, which is typically like an abstraction layer that reduces complexity, doesn't add complexity.
Yes.
How do you do that when you create customized solutions without creating more complexity, or I should say, introducing risk that is dependent on those people that built it?
Yeah. So one of the key things about customizing software is that under the hood, like internal to CrystalForge Technologies, we produce components. And these components can be stitched together in different weird and wonderful ways to make
Right.
whatever you'd like. So that's the first part, is that it's not that you're going to write, you might write custom pieces of code in between, but the core of it is this reliable sort of engine behind it that chunks through all the data, that manages the semantic layers and that kind of thing. The other thing as well is that now we have the power of AI with us. So that allows us, and a lot of the time when you say, you talk about spaghetti code in the IT field, that usually comes from people doing things in a hurry, or not being intentional about what they're building. So the other part that allows us, and this has been quite powerful in practice, that allows us to keep things clean and tidy and make sure that this is a sustainable system, is we've come up with a number of frameworks of how to think about this problem.
Okay.
So for
Proprietary
example,
frameworks now.
yeah, it's some of them are proprietary. I guess we haven't patented any of them, but we haven't exactly published them either. But the primary principle is to trace the flow of information the same way that a typical chemical engineer would trace the flow of material. And then have that, think about a PNID. It's a very detailed expression of how material flows and how it interacts with equipment in the field. We've got to do a similar thing with the information that's moving around the plant. And just expressing the interaction of control loops the way that we have done in PNIDs is not enough to capture the information flow, because it neglects one actor, the people.
Yeah.
It neglects the people. There's no people on a PNID.
Right.
But information flows to people, and information flows from people and through people. And that's also where the idea of human centricity in our sort of brand Bible comes from, is that the human is actually integral to the flow of information through an operation. The same way that a pump is to the flow of material through an operation. And
that's well said.
Yeah. So using that sort of core idea, we map out the flow of information that allows us not to end up in a place where there's more complexity, but rather where whatever complexity there is mapped out, is well understood, and then can be designed into the vision that the business has for itself.
Right. Okay.
Yeah.
When we talked earlier, you mentioned something. You talked about digital augmentation. I asked that, or I asked a few questions in the to understand your view of transformation, and you said, well, you'll talk about digital augmentation instead of transformation.
Yeah.
Talk us through that a little bit.
So one of the things that we've seen, as in my colleagues and I over the years, is that there was a great effort towards this digital transformation. And unfortunately, a lot of the time in practice, things were being digitized that didn't need to be digitized. It was a case of digitalization for the sake of it, rather than for a particular value-based objective.
Right.
And if you know the mining industry well, which you do, it's always about driving down the cost or increasing the revenue, driving that efficiency factor in order to effectively create more resource with less cost base. And so digitalization, we need to treat the same as we treat any other investment. We don't invest in technology except for where it delivers value back to the operation. And that's the spirit of digital augmentation. It's to say, let's figure out where the value is first for technology to make a difference, and then apply it only there. Let's not even make an attempt to digitize everything or bring everything into a transformative effort, because firstly, we've noted a lot of disruption, so change management becomes hard. Okay. And a lot of digital transformation efforts don't fail at the code level or at the product level. They fail at the adoption stage.
Right. Of course they
do. Yeah, and adoption is a function of your adoption success rate is your change management and the complexity of it. So what is the magnitude of the change that you're trying to introduce? And then that will dictate how much effort is required to adopt that change. And that will dictate how much adoption you actually achieve. So when we look at digital transformation, it's a little bit of setting yourself up for a harder challenge very soon in the adoption stage. And then at the same time, some parts of it don't add significant value to the operation.
Yeah.
So what our philosophy is to say, let's do a business case to figure out, based on what we know about the operation, based on what we know about the technology, where will the technology add the most value? Let's implement it there and integrate across all of those value cases. Not to say that you can't implement something if it doesn't provide direct value. We're also talking about intangible value here. So for instance, we talk about data availability in our decision intelligence framework. Data availability is not that there is data somewhere on a historian or in a LIMS server. It's that if you are authorized to access that data, you should be able to get to it in under 10 seconds. That's data availability. You see, so that's an intangible thing. I can't tell you how much money that's going to make your operation, but it's still a value point that we will say this is valuable and therefore must be implemented. So firstly, we've got to expand our definition of value to include things that are not tangible, but still extremely valuable. And secondly, we've got to then target the technology to value. And that's digital augmentation. So
I see that, well, I read that PwC in their 2024 mining report, they said that mining spends, if I remember correctly, about 1.5% of their revenue on IT. And then in manufacturing, it's closer to 5% that they spend of their revenue on IT. And so that means that mining has to be much more value focused, right? They've got to pick the priority problems to solve, because they don't have such a large budget to spend on this kind of thing. Now, my question to you is, whose budget do you use? Is this an engineering budget? Is it an IT or an information management budget? Is it a management consulting budget? Where do you fit into, or whose problem do you solve on a typical operation?
So a lot of the time it differs based on the client and how they set up their internals. But a lot of the time, the implementation budget will come out of some sort of R&D type budget. For business improvement, R&D, operational excellence, those kind of departments tend to be the ones that foot the bill for implementation. And then when it comes to the ongoing support and maintenance and that sort of thing, that usually goes to then the IT department. And the reason is that the implementation of a system like this is directed by the industrial professionals that run the plant. but the maintenance is IT heavy. It's not operationally intensive. Like your superintendents and your process managers are not involved in the maintenance or driving the maintenance and ongoing support of the system. That would be the IT team that manages it once it's fully developed. However, when we implement, we want to be in the department that contains the industrial professionals that actually run the plant, improve the plant, and drive the operational outcomes. And so that's how the budget usually gets split.
Okay. So let's talk about the specific kinds of problems that you encounter most. Yes, you want to create this generic, let's call it a decision-making framework, and you've got a specific decision-making framework that you can talk to us about that, to us a little bit later. But for now, are you talking about specific process optimization? Are you talking about a whole of plant optimization? Are you talking about automation? Where do you solve the most problems?
Okay, so I'd say there's probably we're probably tied for first on two different problems.
Okay.
The one problem that we're seeing almost across the board is how do I manage an industrial operation effectively? And that's not just about the plant or the metrics or the data. It's also about your human resource. It's also about accountability. It's also about, like I said, data visibility and access to information for your organization. That's the first problem that we always end up solving, and that's because most operations have no integrated way of looking at their technical operation as a business, but it is a business. At the base of it is a business. And so there's often a disconnect between the management activities and the technical activities. And what we find is that data visibility and the kind of visualizations, reporting, and just automation of basic business activities is one of the key value unlockers in the first phase of an engagement. So that's sort of how it usually starts off, is that you need to see how much you're spending on tires on your 777s every month based on the whole road condition. It's not surprising, it's not super interesting, but it's something that you didn't know before that you can now know, and you can manage your operation more effectively based on that. Then the second problem that often comes about is once you have visibility of what's going on in your operation, you tend to start to see some things that you are not super happy about. And that you basically end up highlighting inefficiencies, both in the business processes as well as the fundamental operational practices. And so the second problem we usually end up solving is how do you structure the workflows? How do you structure the I've got a bit of noise outside. Can I?
Yeah, we can take a break if you want to, or I can tell you that I don't hear it. So I think your noise.
Close the door for me. Tell me where to start from.
Okay, you were carrying on about the second part.
Let me start again with the second part.
Yes.
So yeah, once that first problem is solved, it exposes a lot of the issues that the business has. Once that happens, we then go on a holistic plant level optimization, which speaks to the flow of material. So we always go people, process, systems, right? So which systems should connect to which people, should connect to which processes, and how do we move that entire activity along more effectively? So the concept that we've I don't know if we've come up with it or if someone else has come up with it, but that we use, called the information value chain. And the reason why this is a little bit esoteric is because it's about the flow of information. So let me give you a typical example. One of our clients has 24 operations, and they're all open cast mining operations. They have a centralized fleet that they use across all these operations, and sometimes they have to move equipment from one place to another for whatever business reason. That process in a normal situation would take them about 10 days, 10 to 14 days, because of the fact that someone has to now email a company, arrange the flatbed, and there's a whole bunch of logistical operations that need to happen. And this takes unreasonably long to do. And then when we put in the business operating system, which is that problem one thing, is that suddenly now the executive who makes the decision to move the machine simply moves it on a user interface. And then there's a workflow that triggers, which sends out all the relevant emails, gets everything in order, and the machine is ready to be moved within 3 to 5 days. Okay. Very simple example to keep it, but to keep it sort of layman's terms. But you can imagine that in a processing plant, when you're operating a flotation circuit, there's also a decision tree there. There's also execution steps there, and there's also reactions and analysis that needs to be done for you to figure out what reaction you should take. So the second problem is usually some sort of recommendation engine that allows the operation to produce better decisions about whatever decisions they find to be lacking in that first part. So, so usually that takes the form of specific process optimization, because we are chemical engineers. So, you know, we know how to optimize a thickness circuit. We know how to run a leach plant, you know, that kind of thing. And baking in those operational best practices into the organization in a way that unleashes the team. So we go in with the approach of human centricity, which I've mentioned before. And so the idea is unleash the team, unleash the business.
Right. Okay. So if you look at that kind of business flow of planning and then execution of the plan, followed by monitoring, decision making, recommendation, and re-execution of the recommendations. Am I correct to say that you fall more into the monitor, decide, recommend phases of that cycle?
Yeah. So usually what we would do is we would identify what problems in the operation contain the most value. So typical example would be, we looked at an acid leach plant not that long ago, and we found that while the leach efficiency was quite good and they were getting most of the metal into the solution phase, when it got to the countercurrent decantation circuit, they weren't washing very effectively. And so a lot of that solution phase material that they worked so hard to recover up front was being lost to the tail in the CCs. In that case, the data reveals the problem. And then we would work together with the operation. This is the other thing, it's co-created. Usually, it's not like the usual service provider client relationship. It's sort of a technology partner sort of thing. And it organically sort of gets there over time. We usually come in doing a particular service. After a while, it's a technology partner, and all the technology implementation goes through us. But let's go back to the example. So you find that, you know, your washing is not that effective. The guys on site have tried a bunch of different strategies to try and fix this. including changing the flocculant and modifying some of the way that the circuit operates, that kind of thing. We can then send someone in to have a look and say, okay, based on what we've seen and our expertise and what the data is telling us, we'll model the circuit, use machine learning to try and predict different circuit conditions and how they would impact the recovery on that circuit. And once we've figured out what the lever is to make the difference, or what the strategy is to make the difference, we then recommend that and implement the technology to make sure that that keeps on happening.
Right. Yeah. Okay. That does clarify it. It's not always that easy to implement technology, and in, for that matter, consulting. Maybe consulting is the wrong word. Advisory services in organizations where, firstly, they sit somewhere out in the bundus, so connectivity might be a problem.
Yep.
Now you want to monitor something, or you want to fix something, but you don't have continuity in connectivity. So I'd like to just hear how you solve that problem. And then I also want to talk about having identified problems and being people-centric. How do you not step on toes, or what do you do when you discover issues that are people-related?
So it's a good question. The first part, I think, is easier to answer. So how we deal with connectivity issues. So typically there's multiple stages of protection, shall we say. At the base level, though, what we do with our technology is the data management system that underpins our technology is best in class. So we get something in the order of 94 to 95% compression on all data that's being moved across the operation. And what that means is, firstly, the packet that you're transferring is that much smaller. So that's the first thing that helps us a lot. So for example, one of our clients recently, when Starlink got banned, suddenly had a lot of connectivity issues. But due to compression, they could still run their operations on a 3G connection. They didn't need LTE or 5G to be able to run their operations, just on compression alone. Then in the software itself, there's a module or a service, we call it, that caches all of the information locally and allows the user to continue to operate locally. And then as soon as internet connectivity becomes available, it'll just beam that through. In very remote locations, remember, we also have a hardware division. So in very remote locations, we can put in LoRaWAN, so like a local access point that's able to then transmit. I think it can receive like 350 kilometers line of sight. Usually you put these up on a little balloon or whatever. And that's like your last ditch effort to make sure, and that'll make sure that you have connectivity. But between the caching and the compression, we don't find that people have many issues. Also, just being smart about how you transfer data. Remember, when we implement, we are implementing on the premises a lot of the time. So there's the cloud services and all that, which people who know they have good connectivity will go for cloud. It's a bit cheaper as well, just because the infrastructure is shared and that sort of thing. But if you want to go on premises, and a lot of our clients do, I think probably 80% of them do, especially out in the DRC and sort of middle of Africa and up, people need their data to be on site, and they want it to be on site. So a lot of the time, we're not even transferring that much data, and we can use the local area network, just the Wi-Fi route on your operation, to move data around if you have no internet as well.
Okay,
So
so let's move on to the people thing, maybe as a last area, because I
yeah,
think that's one of the most interesting ones.
so
You must deal with customers who gladly receive you and not so gladly discover that that they don't want you there anymore.
yeah, so stepping on toes does happen. Um, the One of the things. Okay, let me just give you some facts.
Mm,
Um, let's say it's been more than once that there's been sort of court indictments to stop our technology going into operations by people within that business. And there's been more than once that we've lost the contract because of that kind of thing. But at the same time, by the same token, there's been lots of instances where a client is extremely happy that their business has uncovered and gotten through whatever was hiding in the data.
mm,
So the question is one of will. Is the client willing to go through a little bit of pain in the short term in order to get their business, get their operation out on the other side of that,
mm,
where there's no more firefighting, there's no more sort of desperate scurrying around and um, crazy engineering sort of nightmares that come up. There's this sense of calm once everything is transparent and
mm,
available and so on,
mm,
because everybody knows where everything is and how everything works, and it works
mm,
quite smoothly.
mm,
So the question is usually how willing are they to undergo that initial period, and how much effort is it going to be? So for some
mm,
businesses,
mm,
there isn't much to discover. You might find, okay, they lost a couple of trucks here and there and they weren't aware of it, which is pretty minor, believe it or not.
that does not sound right to me, but okay, I'll take your word for
So,
it.
data doesn't lie, right? Um, and once you pull all the company's data into a centralized sort of repository where they can look at it and they start looking at it, the other thing is that I will usually build a tooling for them
Mhm.
and point them in the direction of whatever the mess is that we found, but maybe not overtly point it out just for their benefit.
Right.
Um,
Yeah.
and our clients are extremely intelligent people. You're dealing with
Mhm.
high-level engineers and executives, and they very quickly pick up what's going on.
Mm.
Um, and yeah, it's usually the case that the technical people are always on our side, so that's great. Um, and more often than not, people who were the greatest opponents of our systems end up
Mm.
being the greatest supporters of our systems after we've gotten through the part where we kind of annoy them a bit and offend
Mm.
them a
Mm.
bit, and it's usually a case. It's just human nature, you
Mm.
know. It's like whatever I've been doing, I'm attached to, and I'm attached to the way that I've been doing it because I came up with it.
Mm.
And in order to see a better way, I have to someone has to prove it to me firstly,
Mm.
and that's what we take all the effort we can and pour it into proving this to them that look, this will improve the business, this will help you, this will improve that and that metric, and it's going to be a little bit more work in the immediate term, but later on it'll be fine. And then there's that 5% of cases where there is fraud or there is some sort of ulterior motive or something untoward. And
Mm.
I know that that's something that people want to talk about a lot.
Mm.
I get
Mm.
questions about that, like a reasonable amount, but it's literally probably 3% of the time.
Mm.
Um,
Mm.
and more often than not, the business is already aware of what's going on at
Mm.
some
Mm.
level. And it's just a question of whether they're willing to do something about it or not. And
That's really fascinating. Yeah.
From our perspective, we'll happily walk away if they don't want to continue. But to me, that's not a failure either.
Yeah, of course it's not. It's like showing if someone has very bad data, that in itself is valuable. If there are horrible results on the report, it's not the report's fault. It might point to a fault in the cleanliness or the quality of the data, etc. And that's not a bad thing. Pointing that out, it's a good thing. So those kinds of discovery loops exist everywhere. Ahmed, we're out of time here, but I want to end off by coming back to you personally, and a question that I always ask my guests on the podcast, and that is, when you're not busy solving problems on a plant, you're not busy finding out some new AI technology or monitoring technology or decision-making framework, what is it that you do to keep yourself sane?
So I don't think I've ever been successful at keeping myself sane entirely.
There was an assumption built in there. You're right.
So some of the things that I do for fun, let's say, I've been playing with making music with AI. That's quite interesting.
Okay.
Yeah. So I mean, I've got all the infrastructure and I've got all the know-how. I might as well have some fun with it. And like video generation and music and that sort of thing. And how do you think about like producing a melody with AI in a creative way where you can still direct that? It's quite a new and interesting area. I often go on hikes and enjoy the outdoors and nature and that sort of thing. I prefer like a good multi-day hike will get you in the right headspace for whatever it is that you're trying to do thereafter. So I strongly recommend it. And I guess the other thing is just spending time with the family and with my people, whether that be colleagues or friends or family. I have a 1.5-year-old daughter, so that's
so you don't really have much time on your free time on your hands. That too shall change. Don't worry.
In time. But yeah, we're enjoying the little one and that sort of thing. So yeah, I think it's lots of creative stuff, because my typical is very analytical and very so I tend to, when I'm in my downtime, take a walk, jump in a lake, literally, not figuratively, spend time with the family and friends and that sort of thing. So yeah, that's me. And obviously, I always do research in my free time. I don't know if that's obvious, but my lifelong passion has always been learning, and that has nothing to do with work or profession or whatever's interesting on the day. I'll go down a rabbit hole happily, as you can tell.
Well, thank you so much for sharing some of the rabbits with us. And we wish you all the best with CrystalForge and forging ahead, solving problems for plants, and making it easier for managers to find real problems and solve them quicker. Thank you so much for your time and for being on the podcast.
Thank you, MP. Really enjoyed it. I think I should probably mention this. If you want to know what we do in a nutshell, in a sentence, it's creating clarity from chaos. That's what it's all about.
That's really good. That's really good.
I'll leave you with that. Thank you, MP.